Let's create a model. We'll call this model coal transportation. File, new model. Coal transportation is the name. We'll change the model time units to hours, like so. Here's our model, our project, and we'll see the new feature of database, which is the new feature in 7.2, and we'll use this internal database to populate various tables from an Excel file, which we're reading in here. And we see there's a number of tables that will be imported. Let's take a look at these tables and see what data is in there. So we have parameters, ports, and production, and we can see the records that are inside these tables. The city name, the states, the capacities of the various vehicles we're going to be using in this model. Let's start creating some agents. The first agent will be a population of agents, which we will set as the seaport, or name as the seaport rather. And we will use the database table to fill in the parameters associated with this agent. In this case, it'll be the ports. And there we see the port name as well as the state, and we're going to add a new parameter called the GIS location name, and we'll associate that with the port name from the database. Assign a shape to this. And identify the environment as a GIS entity. Therefore, we will get a GIS object or a map in our model automatically. Let's position that so that it's centered on the screen. And let's create another agent. Drag that from the palette. Create a population of agents. Follow the wizard. Name this agent mine, which will be used for the coal mines. And again, use the database to populate the attributes or parameters of that of the agent. In this case, we'll see the coal mine name, and as well as the capacity of the coal per week, trains per week, and associate the GIS location name to the coal mine. Assign a shape to that. Choose a shape. And now we have our coal mines defined and our ports defined. Now let's run the model and watch the model select and place the agents at the locations defined in the database. So let's go in and zoom in so we see that a little easier. Zoom in North America, and we'll run the model again, and you'll see the mine placed in Wyoming and the ports on the eastern seaboard, Baltimore, New York, Savannah, Georgia, etc. And we can highlight and select a particular agent, such as the ports, and look at the various properties or attributes that are associated with those agents, such as the port name. And we can scroll through the number of ports. There's the first, the second, the third, etc. port, and you can see there are different names, different locations for the ports. Okay. Now let's add a terminal agent. And we'll bring the agent in from the design palette. This will be a single agent. And we will name this terminal. And it's a single agent. Will not have a shape. And complete that process. And the terminal is the location of the delivery point for the coal from the coal mine. And so we're going to name and specify that here inside the properties of the terminal. And that will be the Newport News port in Maryland. Excuse me, in Virginia. Newport News, Virginia. Now, let's give some process to the mine. So we'll go into the mine agent, and we'll use our process modeling library to create some logic for the trains to deliver the coal to the terminal. So here we have a source block. Now we're going to create a new agent from within this agent, and this will be called the train. So we'll name the agent a train. We will give it a shape, which is the locomotive. We'll add a parameter. That parameter will be called capacity. Leave it as a double. And now we've just created a brand new agent called train, and it's being sourced at the mine. So we'll specify where that location is. It's in a geographical place. And the name of that will be the coal mine, which is the city at which, or the location of the coal mine agent itself. And it'll have various parameters such as speed as it moves across the space in the model, across the map. The arrival rate is going to be defined as the parameter that is in the trains per week property of the mine, which we're reading in from the database. And we have 10 trains a week coming in from the database. Now we'll define where that train is going to go, and it's going to move towards the terminal. And that terminal, that location is found in the main object or the main class and the property terminal or location terminal. Now we'll create an icon for the mine. We'll drag that shape out onto the palette, onto the canvas from the palette. It will need a port to connect our logic, our logical blocks to the icon, and we'll call that an icon, and we'll connect the move to block to the port of the icon. Now you'll notice that when we go back to main, you'll see the mine agent is now represented as an icon rather than the generic agent icon. And it has its port associated with it as well, which we'll use in a little bit. Now let's add some logic to the C ports. Let's select the C port, and we're going to use the new fluid library to manage the fluid coming in and out of the C port. So we'll create a tank. The tank will have a certain capacity. The capacity is something that we're reading in from the database, and so we'll search for that with this process right here and associate the capacity from the database, from the capacity found in the port table. Set an initial value of the material in the tank, and we'll continue now. We'll add some more logic with valves and conveyors. So we'll add a fluid enter block, a bulk conveyor block, which will connect one object to the tank, a valve which will control the tank's flow, and another bulk conveyor block to a fluid exit, which is where we're going to use to fill a tanker as it moves into a port. We'll set the various parameters of the conveyors in terms of flow rate, as well as the valve, if it's initially closed, and you can see the properties here associated with that object of the valve. And the same thing with the exit conveyor of the tank, its flow rate, tons per second, etc. Now we'll come back to this and associate the create the logic for opening and closing the valve and filling the tank and delivering from the tank. So now let's create another process which will be used for when a train arrives to a terminal and delivers material to the tank of a terminal. And we use our fluid library where we're going to convert the agent to a fluid, and this is what we're going to use to take the material out of the agent, take the coal out of the train agent, and process that and flow that into the tank. So let's move the blocks a little bit to get a little better appearance. Now we'll create a fluid merge block and connect this conveyor to that, so we can actually bring material into a tank from either a tanker vessel or a train. So again, the agent to fluid transformation block is used to when the agent arrives, the train agent arrives, is used to get the material out of the agent into the tank, which is the coal itself. And I'll continue with setting the various parameters of the elements in the process block, such as the capacities and flow rates. Once we've completed that, and now we've established how the terminal is going to receive and deliver materials, what it's going to deliver, and we'll come back to the logic in a minute on that. Now let's use the database, the internal database, to pull a reference or a query to set the capacity of the trains. So we'll select the train object, the train agent. The parameter capacity will be set to a database reference. The parameters table, pointing to the parameters table, pulling the capacity of the train of the object, and we're going to set that to train. And so we've just established the capacity of the train using the internal database, basically a SQL query. Now let's create a new agent called the tanker. This will be the vessels using to transport the coal from port to port. Give it a shape, which is a vessel. We'll add a parameter which will be called capacity. We will not create any agents until the model initiates. Now again, we'll use the database reference, and we will set the capacity from the database, the table parameter capacity ton based on the tanker from the table parameters. Now let's go into the seaport and let's continue the logic there. So we have a set of logic for when trains deliver material and when a tanker delivers a material to the terminal. Now we're going to establish when a tanker receives material from the ports. So we'll create a quick logic sequence here of an enter, and this is a tanker coming into a queue, a delay. This is the delay that we will use to trigger the valve of the tank inside the terminal. And then set a move to an agent, which we're going to specify as the terminal. Now let's create an icon. Add a port for the icon and connect the move to block to the port. And once again, we will see that the C port now icon will be changed back in main from the standard agent icon to this icon. So one of the ways to make modeling more efficient with AnyLogic is the use of extensions. Rather than recreating the logic from one agent to another, we can simply extend an agent's logic to another. And so in this case, we're going to extend the C port logic to the terminal. And so here we see the original C port logic. Any changes we make in this logic will be reflected in any other agent that has extended from it. So the terminal you'll see the changes in a terminal in a moment. So let's adjust the position of these blocks to get a little more room, and now you'll see those changes reflected in the terminal as well. So we'll go back to the palette and we'll create another icon in the terminal, add some ports, to the icon. And now let's create some logic coming into a terminal that the train will use as well as the tankers. So let's add a delay block. And an exit. Connect that to the icon. We'll have a very simple delay, simple probability, a triangular distribution. And the agent that will be moving through these blocks will be the train. So when the train arrives at the terminal, it will be delayed for a short period of time, and then we'll move into this enter block to start to transfer the coal from the train into the terminal's tanks and holding tanks. So let's position the terminal agent after the coal mine. And we'll enable the presentation of the terminal, so we'll see that the terminal will be drawn at the time of execution. Now, for the agents that are moving, the trains that are moving from the coal mine, we're going to use the rail of the overlay of the GIS maps, the data associated with the rail network. So let's run the model, and we'll see the trains moving from the coal mine to the terminal, which has been defined as Newport News, or located in Newport News, Virginia. And there we see the trains moving across the map, and we'll zoom in and we'll see there's a little difference between the actual rail line and the train, and this is purely a as we said before, is purely a positional representation. We can change the resolution of the GIS object from the default of 1,000 meters down to 10 meters, and we'll see that this train now will drive directly over the rails, but the actual route and the distance are accurately calculated from the GIS map provider. And now we'll zoom in and we'll see the train is following the railway perfectly. And there he is, traveling along all the way down to the terminal. So I no longer have to draw my train network. I can actually harvest that directly from the GIS map provider. There the trains are arriving to the terminal. Okay. Now, let's add the tankers. Let's add a variable to the tanker that will define the destination that the tanker will use to go from port to port. And when they deliver material from the terminal to the port, they'll return back to the terminal. And we'll choose the port to travel to randomly. So the tanker is going to utilize the fluid library as well, and it has a storage tank located inside the vessel itself, which we're going to set those properties up. We're going to read the capacity based on the parameter capacity that is read from the database. We will then control the material flowing in and out of the tanker via the valve with logic that we are going to set in the terminals and ports, rather, when the tanker arrives at a port or a terminal. Now let's add the logic of a tanker arriving at a port or a terminal. So we'll edit the agent and add a series of process blocks, a source, a queue, a delay, and an exit, and this will be used to control when the tanker arrives at a terminal and it is receiving materials, and as well as when a tanker arrives at a port and it's delivering materials. So we'll set that logic up, and now we'll start creating and adding the elements to it. So the source is going to be a tanker. And an arrival rate of 1 per hour. And we'll set the number of arrivals to 7. So we'll have 7 tankers working in our fleet. So let's copy that location of Newport News into the place where the tankers will be created. I'll set the speed to 15 knots, etc. Add a queue and a delay. Now this is the delay that will be used to control the fluid or the material moving to or from the tanker to a port or out of a port or out of a terminal. Once it's finished loading or unloading, it'll move to the next port or back to the terminal. And now we will connect the tanker to a enter object or an enter block of a seaport, so that material can actually flow into or be delivered from the port. Now, this delay block is where we will use what we will use to control the material flows and basically turn those valves on and off. So when we enter the delay block, that means we've arrived at the port and are ready to either deliver or receive materials. And so we're going to make a connection of the fluid exit to the actual tanker. And we will control the valve to start moving material to or from the tanker to the terminal. And we will stop that valve when we'll stop the flow when the tank is full, when the capacity has been reached. Once it's full, we'll then disconnect and move to the next port. Which is what we're writing right here. And so we'll choose a port at random. of the ports that we've established in the model. So here we see the connection between the delays and the various functions of the fluid library. So we said we'd come back to the process, to the fluid library logic in the tanker, and this is what we're going to do right now. We're going to, once the material has reached the capacity and we've filled up the tank, we will again make a disconnection and stop the material from flowing. So we'll disconnect the agent from the from this logic block. And we will use the stop delay command to turn off the flow of material from the source to the tanker. And we're setting this as the agent because we could have multiple vessels pulling into a port or a terminal. And we'll do a very similar set of logic or conditions. On entering the delay, it'll make the connection to the fluid enter block of the port it's at, and enable the valve to start to flow material until we've reached the capacity of the vessel, of the tanker. Once we've reached the capacity of the vessel, then we'll disconnect from that pipe and stop the material flowing. And move to the next port. Let's make a connection from the terminal to the port. And do a similar connection because the source is only going to happen once of creating the tankers, but as the process repeats, the tankers will move from a port back to the terminal to pick up more material. So we've made that connection from the terminal icon port to that queue block. So let's run the model and take a look at what happens. Speed things up. Trains will be delivering to the terminal, and you see vessels moving to various ports, but it clearly shows the vessels moving over the rail tracks from port to port. That's one of the things that we haven't done yet, is add in a shapefile which will have the maritime routes of the vessels so that they can move across the water instead of over the railway, which is what the default is set to on the GIS map object right now. So yes, tankers do not move over the rail tracks, so we'll fix that right now. So let's add a shapefile for the maritime routes. Do that. I've downloaded the global maritime routes, or routes rather, for the for all the shipping lanes, and we'll zoom in on the area of interest that we have, which is the East Coast, eastern seaboard of the United States. And we'll convert these routes to a network. And we'll do that to convert those to a shapefile, shape markup. And we've just converted the shapefile that is displayed within the viewed window into a series of networks. We can now get rid of the shapefile, and here you see all the points and nodes. And so we have a network now that we can work with. So let's go to the tanker object and select the appropriate network, which is going to allow the ships move from port to port via the sea lanes. Let's run this model and take a look at what we see. And here we see the vessels moving from port to port, the trains arriving to the terminal, and they're moving across the sea lanes. Here's a ship going to Savannah, returning to the terminal, etc. Make it a little easier to see. Let's change the color of the let's change the size of the vessels, make them half as big as they were, and let's go ahead and change the color of the object, the fill color. Something's a little easier to see. We'll go to blue, and we can run this again. And we'll see a ship moving from port to port, following the sea lanes that we downloaded from the shapefile and overlaid on our GIS map. And there, this ship is going out to what looks like New York. And once it's unloaded, it'll return to the terminal. And so on. And here are the trains following the rail network. Coming from the coal mine and moving to the terminal to deliver the coal, etc. So we can get rid of the shapefile now. And let's add a view area of the ports so we can take a look at those when we execute the model, and look at the logic associated with either a terminal or a port. A little easier to demonstrate what's going on here. So here we see the new fluid library. We can go to a port to port. As we click on the various ports, we can see the activity inside the port. We can see material flowing into the tank, valves opening and closing, ships arriving, trains arriving, etc. Now let's add an additional mine to the data set. So we'll actually go into the database and add an additional mine as a source. So let's do that. We'll add another mine. It'll have a similar capacity, identical capacity of 10 trains a week. And let's click the automatic import upon startup. So this is going to go in and update the additional mine that we've just added to the data source. And we see now another mine in West Virginia that is producing coal and delivering that to the terminal. Let's take a look at the new database functionality and the capabilities that we've integrated with AnyLogic. You can create log files from the data and have them stored in your database from the performance of the model. And we'll do that right here. We'll click on the enable the log file, and let's run the model, and we will then see the type of information that is collected. So all the activities, events, occurrences, etc., the metrics of agents and process blocks, etc., are all captured in the log file for you to go in and drill down into and review. It's a very useful tool for debugging purposes as well as for further analysis. Like an example, we can take a look at the agent log, and we'll go in and filter out which agent we want to look at. So we can sort, filter. You can see the events, or rather the total distance that they've traveled. Here's a movement record, the speed at which they moved at. We'll take a look at some of the other values here. You can see that all the movements are captured. Another example would be the flowchart entries log. You can see exactly when something is coming in or leaving a particular process block. So, and this is an example of sorting or filtering by the trains that are coming into a particular block type, the source, the move to, etc. You can see when they've done that, what block they've come from, etc. It's a very useful tool. You can export this as another database file, another database table, which then can be used for other applications, or it can be used by you could use this as an input into the model for further analysis, etc.